We need to move on now to the future briefing on Edge, Compute and the CDN. So this is the first of our 3 future briefings, and we're going to hear from an operator that's leveraging experience in running at-scale distributed compute networks and edge compute to facilitate content delivery. Heather, Michael, are you out there?
We are. How are you, Dom?
Very good. Running a little bit late here. It's just coming
that's
up to
okay. Y'all were having a good time.
So, I haven't forced myself with any extra coffee because I'll just start talking rubbish if I do that. But
I was just thinking it's almost past midnight for you.
Yeah, and later still. So, and we've got Michael with us as well. Michael, are you out there?
Yes, hello. How's it going?
Look, guys, why don't you introduce yourselves, and then I'm going to actually sit back and let you guys have a chat for a while and tell us what you've been up to, because I'm just going to leave it over to you. So, Heather, take it away.
Sure. Hi, everyone. I'm Heather Mellish. I'm the Principal Go-to-Market Specialist for Edge Services here at Amazon Web Services. Edge Services is a moniker we use to cover a couple different services. One, Cloudfront, the Amazon Content Delivery Network, and Web Application Firewall, and DDoS, our Shield Advanced perimeter, make up our perimeter protection. And I'll talk a little bit about our agenda today, but Michael, why don't you go ahead and introduce yourself, and then we'll kick off the agenda. And great, you've got your presentation up. So.
Hi, I'm Michael. I work with CrunchyRoll as Vice President of Engineering, run a few teams, including the Video Infrastructure Group, and who handles CDN and Edge Compute and playback APIs and that sort of fun stuff. Prior to that, I was with a company called Kaltura, who did a lot of online video platform work back in the day, including some of the HTML5 standardization process. I help organize some of the open forums around standardization discussions, FOMs, and participate in a lot of conferences. So I'm sure some of you have seen me before.
Great, thanks, Michael. It's great to have this opportunity to chat with you again. So we'll start with a quick overview. Michael's going to be talking about Katana, which is an edge playback orchestration solution that they've put together at CrunchyRoll, and we'll dive into what is playback orchestration. We'll talk about manifest level manipulation for AVOD, ultimately wrapping it all up about the importance, which a lot of us are very focused on, is serving our global audience with a low latency solution. And then we'll dive into the lessons that Michael and his team learned and kind of their next steps is how is their solution going to evolve. So Michael, why don't we start with a quick update for the audience on CrunchyRoll and what your team is responsible for and what you guys have been up to.
Sure, should we jump into the presentations?
Yeah.
Can I present? Doesn't, yeah, okay. So yeah, as Heather mentioned, we've been working on a project called Katana. It's basically playback orchestration, manifest level manipulation, and sort of a solution that we looked at in terms of delivering video to our audience globally. In terms of the what is CrunchyRoll, we're about a 3 million paid subscriber SVOD property. We also have an AVOD component that is basically the top of our funnel, which is a much larger group of individuals as well. We're part of that 70 million registered. Our users watch 100 minutes a day on average. They're really passionate fans of the CrunchyRoll content. And so that all maps to a lot of video streams. And especially recently, in the last few years, our global audience has grown quite a bit. And as part of that, we started looking at our performance globally. And to do that project, we were previously using a QoE, a dedicated QoE provider, but then we shifted to building our own QoE platform based around this concept of client-side rollups, which enabled us to get a lot more fine-grained performance data around sort of profiling the player globally, and which led us down the path of global latency and multiple connections that a given playback session needs to instantiate in order to get to video playback was the principal challenge in our video delivery. Secondarily, we had a lot of, we were also working with a SSAI vendor and a multi-CDN provider at the time. but they face some limitations that we wanted to try to overcome, which we'll touch on as we look at the solution in more detail.
So were some of those pain points that you had as far as, I mean, when you're looking to change your entire solution and you're looking to scale globally, I would imagine if you don't have that infrastructure globally, that's a pretty, pretty daunting task.
Yeah, as I came into CrunchyRoll a few years ago, we were entirely in a data center. So it was a big project to get us into the cloud, with an AWS cloud that we mapped into. And through that large project, we only landed in a single region within the AWS cloud platform, right? So we faced the challenge of like, wow, we have to spin up regions in LATAM, Europe, Asia, South Pacific, India. Like, how are we going to go from zero to everywhere really quickly in order to address our global delivery challenges? And so that
I would imagine in a year like 2020, your consumption has probably gone through the roof, and the pressure to be in those locations is probably even greater.
Right. So just we wanted to deliver as best of quality service as we could globally, and through kind of sort of this more detailed telemetry effort, we were able to see much more clearly pinpoint sort of the areas that were running slow, and also I mean, it'll become this kind of gives you a sense of where we started. There's just a lot of different pieces involved in pulling everything together in order to deliver the first frame of video for a user, unfortunately. The streaming service would, so basically the CMS would hand out sort of an entitlement and check entitlements and hand out a playback URL. But there's a lot of other services involved, including, sort of a service that has to call the ad network in order to construct a SSAI VMAP file, which is basically, if people are not in the ads industry, that's a sort of a definition of ads and content, like a timeline with beacons and various details around what needs to be triggered as you play back the stream relative to registering that an ad was displayed. That VMAP has to be time aligned with your manifest file, which is a video for like Dash and HLS manifest, which also needs to be retrieved. But of course, your manifest file itself is a multi-CDN manifest file, as we mentioned earlier. So that's another service that has to be, hopped in between relative to multiple different providers providing manifest manipulation. And as you can see, that starts to get a little complicated. And then you add on top of that the fact that all these users were coming to the service from different geographical locations that didn't always map directly to the available infrastructure from these different service providers, which meant you had a user sort of flying back and forth between Miami and then back to Brazil, then back to Mexico, and then back to Brazil.
Latency is critical. I think for those even who don't have experience in server-side ad insertion or even ad insertion in general, seeing this ad playback, albeit simplified, yet looking complex, each step could introduce latency, especially if you're, as you said, you're bouncing back from India to LATAM to the US to EMEA and whatnot.
Right, exactly. And then there was also, these are all content protected streams. So these are DRM protected streams. The manifest itself is all tokenized. So every reference to a URL has to be signed. So these are a lot of different services and components that kind of sprawled across multiple services that resulted in, not great performance. So how could we do better? We introduced the concept. So we sort of looked at like, how is this challenge normally addressed? Things like, GraphQL have described mechanisms for a client to request the resource graph that they need in order to display a given user experience. So we borrowed some concepts from that and thought about, what are all the resources that the player needs to signal to the service in order to get back its playback graph within a single round trip. So, things like, am I a Dash or HLS player? Can I support AB1 or HEVC? Can I, in the case of CrunchyRoll, we have soft subs and hard subs. in the case of ad identifiers and device properties, all the macros that would potentially be substituted, it's able to construct this request graph, and then the idea is to send that through to get back a single response. And so that gives us, here's an example. Like you may be requesting for this asset, and then instead of just requesting the URL to the Dash manifest, you also embed the payload of the manifest itself to avoid going back for another round trip in order to get something that is already in the Lambda cache, which we can get into in a little bit later.
It looks like you're avoiding, just even seeing these numbers, there's some significant latency reduction that you were able to achieve here.
Right. So then we're able to, so things that were previously distinct services or companies in many cases, were all sort of collapsed into a single Lambda. And so all of our stream manipulation happens natively with one service, and enables us to, resolve a lot of these, basically the request graph in a single geolocation. And the only outside call that we would make is to the ad server in the case of AVOD, and fully resolvable request in the case of SVOD.
So it's clear when you're putting together the solution that you need to be able to have the flexibility to plug and play all of these different solutions and do the testing. And I'm sure we'll get into that later, like best lessons learned. But talk a little bit, if you could, just about what that's, being able, one, to have a solution that offers you that flexibility, but what it's like plugging and playing and being able to handle that. Like you were saying earlier, when you have the player and the ad server and the CDN and the origin, there's, 4 distinct companies or 4 distinct services. So being able to tie that together was probably a shift, but also a lot enabling and empowering you guys with a lot of flexibility, I would imagine.
Yeah. So yeah. It certainly was work to internalize some of these projects, but it also gave us flexibility that we historically didn't have. So yeah. Well, we used Lambda Edge in case people have gathered that.
Yeah. For those who are not familiar with Lambda at the Edge, it's a feature of Amazon Cloudfront that essentially lets you run your code closer to your end users, and gives you a lot of flexibility, and inherent just improves performance and latency. And so this is a great example of taking advantage not only of your AWS cloud journey, but adopting Lambda and Lambda at the Edge, and ultimately Lambda at the Edge is a feature of Cloudfront as well.
Yeah, and I think we were certainly doing something a little bit beyond like what the base, just some learnings that we had from the project. It's the Lambda Edge is really the regional edge. So it basically runs in all the AWS regions, which is still many regions and very close to most, almost all of your users on the planet. The memory allocations, traditional Amazon style stuff where you have the memory allocations of your resource mapped to the compute that is allocated to it as well. There's not a elastic, so there's no in-memory cache, but this goes back to our Katana name. This is sort of a stateless service, so it doesn't depend on a sort of shared session or elastic cache construct. It's all running through Cloudfront as a secondary cache tier. Observability is something you're going to want to work through CloudWatch to facilitate that, and then of course,
I love how you have CloudWatch as your friend.
Yes, you will need to use CloudWatch if you're going down this path, I think, because it very much is the tool of choice, and it also lets you kind of have a lot of flexibility. I didn't put a lot of graphs around that into this presentation, but it gives you a lot of flexibility to sort of visualize arbitrary dimensions of your data, because it's basically just a visualization tool on some JSON that you're outputting on every request, and so. You can, visualize ad fill, or visualize, how many ingest requests are happening on a per, aggregate basis. Your regional house, like we have house ads versus non-house ads. Lots of stuff that traditionally was kind of, built around separate telemetry solutions just kind of flows through the the CloudWatch metrics platform.
When you're looking to bring this all to market, take me through, I guess, or take all of us through what's that timeline and kind of your A/B testing and plugging and playing of all these different parts to the puzzle.
Yeah, the approach we took was largely to replace in place. So that meant that, so even though this is like the end state, which we're not actually 100% there yet, each piece was replaced individually. So for instance, the manifest manipulator for the multi-CDN use case was something that we tackled first. And so it serviced the same URLs that we were serving before, but now just through this Lambda. And that's how we sort of built out the service one by one. We're taking all the pieces that normally were served by other services, putting them all into this aggregator, but also servicing those URLs directly. So in other words, we're able to start rolling out to all of our, to solve the multi-CDN manifest manipulation problem as a first step, as an MVP of the product, and then we just kept taking it beyond that.
What was the timeline?
Let's see. I think we started about March. I think.
Okay.
Yeah, let's say March is when we started. Pretty
quick.
Yeah, there's a lot of different.
For something this intricate on a global scale, this is a pretty quick time to market.
Yeah. Let's see what else. Okay, so looking at the multi-CDN considerations, like again, we wanted it to be fast, obviously, as with these things. No 302s, no limits of DNS. Like in the previous session, I know you guys were talking a little bit about manifest versus DNS based switching. We're definitely in the manifest camp. There's a lot of benefits around sort of protocol specific failover, so you can list failover segments within the manifest itself. We have the server just supplying the recommended order, so players can still negotiate on top of that. So if the player faces congestion, it can just fail over to that list of CDNs that are packaged in the manifest itself, so we don't have to come up with a new standard around that. And clients that just play vanilla vanilla dash or vanilla HLS still have total failure failover as part of the same construct. So
that failover is that you're just about to get into is inherently built in to the player, something that you guys are.
So dash and HLS specifications define mechanisms to list alternate URLs for all the segments, and in our case, these alternate URLs are alternate CDNs. But we supply the sort of recommended order to the client in order to facilitate both our our rules engine deciding which CDN a given region or ASN should be mapped to, or what or if there's performance data that is informing that. Yeah, and I think another mention like that we gained a lot of flexibility in our allocations. We could modulo hash the content ID for allocations, which is just a fancy way of saying that we're able to allocate CDN traffic based on content affinity, which, so say you're only sending 5%, so say you're sending, or you're testing a new CDN and you're sending only 5% of traffic to them because you want to test them out, you can still give them a representative cache hit ratio for that region through content-based affinity mappings. So that just means that, a given CDN has a representative performance because they're able to get that percentage of traffic, but just on a per content title basis. So all the traffic for a particular title, that sort of thing. And then SSAI within the solution is also live today, also kind of sits in place type solution. And that was basically put in place through the Katana system as well. Here, I think one of the key innovations was kind of the deterministic hashing of the ad stream URL. This basically let us resolve quickly the ad lookups so that when we're building these composite, multi-period dash sequences or the HLS discontinuity sequence, we're able to have a solution that works well. So, yep. What else did we do? Oh, the ads are ingested with the same engine in this case. So this enables us to maintain perfect alignment of the encode profiles. So, when you're working with a vendor for SSAI, sometimes you have to sort of pass them off the encode settings, and if you ever want to make changes, you then have to coordinate it with the respective party. But here we're able to have perfect alignment, and it makes it a lot easier to roll out new codecs and that sort of thing. And of course, makes ad blockers work more challenging because the segments and content are indistinguishable from the manifest level introspection. And then, of course, everything combines. So the same multi-CDN engine, the same backend that is serving all of our content, enables a seamless mapping of the same URLs, because the content CDNs are the same as the ad CDNs in this case. And so things are able to sort of build on each other. Okay, this is just a diagram of it. We don't need to go into that too much, but basically
it shows the different services and how they're working together.
the different pieces of the AWS ecosystem. Yeah. So you have your Edge Lambda, then you have your sort of CloudFront cache node. We have sort of a just-in-time packager that's built on sort of the Kaltura Nginx open source pod packager. S3 obviously hosting our fragmented P4s, the API gateway hosting the SNS messages, and the a system for passing off the ingest requests into the encoder.
I'll give you an A+ for transcending AWS services there.
Right. And then I guess another lessons learned element here is just sort of around caching in the right places, minimizing or maximizing Lambda Edge performance. Something important to keep something that we didn't know when we first started it was just that the Edge Lambda has a in-memory cache that can be leveraged and has persistence. So even though people generally think of Lambdas as just sort of running and then disappearing, that they're sort of fired up and they continue to handle requests in sequence as many as they can handle. And this enables us to leverage that in-memory cache to service a lot of our requests within less than that 10 millisecond response time that we were talking about earlier. If that fails, we fail over to the CloudFront Edge cache, which operates pretty similar to a normal CDN, though we don't have to manage URL signatures there or anything, because now the Lambda is responsible for that. So that's kind of the summary of the project here. I think the really had to work on getting the global audience, basically a system for servicing our audience globally,
is there a region that puts more burden, that has put more burden on you, that this solution and just kind of the scale and latency that you've been able to put together, just being able to expand in various regions? Is there a region that was kind of a thorn in your side ahead of time, or areas that you're kind of growing into
I think anywhere,
over the course of this year?
Yeah, I mean, our origin is based in US West, Oregon. So just as you get geographically further away from that, the pinnacle city would be like Madagascar or something. But, so anywhere like India or, South Australia, anywhere that's very far from the origin inherently has a lot more latency in the model, where you don't have everything, where you can't put everything on the edge, because we're talking about sophisticated manifest manipulation strategies that are not going to be easy to solely put on the edge without edge compute, as with a product like this.
Great. Michael, thanks for taking us through this. I hope that this is, while intricate, you make it seem fairly easy. And obviously being able to work with a provider that allows you to do that is great as well. But thank you for taking the time. And Dom, thanks for having us today. I think we may be just at time, so it was perfectly delivered.
Spot on, everyone. That's absolutely.
I'm a rule follower, Dom.
Yeah, thanks again.
So listen, I'm just going to, while we get Angel into place for the next presentation, I just wanted to throw just a couple of questions to you, if that's all right. What would you, can we just, let me just kill the screen share for a minute so we can get back to full video. So in the whole project, what would you say was your biggest challenge? Was there one single pinch point that, that was the biggest challenge? In fact, there's two sides to that question. What was the biggest challenge within deployment within AWS? And also, can you talk a little bit, Michael, about the decisions that led you to AWS as the partner for this?
Yeah, so just to talk quickly about one of the biggest challenges, I think, was just, you know, changing the engine in flight with these things as they go, right? Like we had to, so there was both the changes in terms of a gradual rollout, you know, so we had obviously, so we were routing a very small percentage at first and then increasingly more percentage as we, you know, look at the data points and confirm that things are working as they should. What's challenging about that is that there was changes to our underlying video infrastructure that had to be made in terms of certain, you know, like the Lambda is requesting new resources, like in this case, like a tokenless URL that had to be authenticated and so forth, which changes our load dynamic on origin. So just carefully watching that all the while we're delivering massive amounts of traffic through this video origin is the challenge. And then in terms of AWS, I think it was a natural fit relative to our existing cloud deployment paradigm. So, you know, all of our software-defined infrastructure, all of our, you know, infrastructure as code and so forth, all kind of mapped in, you know, made it easy for the teams to work more directly with the AWS platform. I think we did look a little bit at some other edge solutions, and I think there's some interesting, you know, things out there happening. So it'll be, you know, I think it's a lively field, and I think we'll continue to see a lot of evolution in the space, and look forward to, you know, looking at how it develops.
And Heather, conversely, what was the biggest challenge for you bringing CrunchyRoll on board? Did you have to bring new things out of beta quickly, or were there any technologies which you thought, yeah, you know what, we need to put this in place so that CrunchyRoll will really find a home with us?
I think it's just really being able to be in lockstep with their timelines, and obviously they're growing. I mean, they're growing globally, and they need a latent global solution. And as you've seen, just even in the architecture of all the different AWS services, being able to marry those together, but also being able to get consistent feedback and being able to funnel that back to the various service teams, and just really being lockstep with the customer, but also being able to gather that feedback, because a lot of it, I mean, Michael's got a super talented team, and he's got the flexibility to plug and play these solutions, but really being able to plug our customers into the various service teams and kind of bring that together. So while we allow you the flexibility to plug and play your solutions, you still have to be able to gather feedback across multiple services and bring that all together to provide a solution on top of one that really latency is super important, but so is that global scale. So just, you know, honestly, a lot of it is communication feedback and really being able to work with a partner such as Michael, which has been great. And having them, you know, test you to your limits.
Absolutely brilliant. Thank you so much to both of you for a very engaging presentation. It was excellent.
Thanks for having us.